Hey there, young scientist. Today, we're going on an exciting adventure to learn about some really cool stuff. Force, different types of force, motion, and Newton's laws. So grab your curiosity and let's explore the world of force, motion, and Newton's laws together.
Good day, everyone. In this video, we will tackle force. So what does force mean to you? So let's define force. Force is a fundamental concept in physics that describes the influences that can cause an object to accelerate, deform, or change its state of motion. It is defined as a push or pull of an object resulting in the interaction between two objects or due to the presence of a field. According to Newton's third law of motion, for every action there is an equal and opposite reaction. In this case, the action is the force you apply to the door by pushing on it. As reaction to this force, the door exerts an equal and opposite force on your hand. In this case, the door resulting in a change in its state of motion, causing it to open.
Gravitational force is a fundamental force of nature that exists between any two objects in the universe that have mass. The concept of weight is also based on gravitational force. The weight of an object is the force with which it is attracted toward the centers of the Earth due to the gravitational force between the objects and the Earth.
Another kind of forces is magnetic force. So magnetic force can be found all around us. Did you know they can be attractive or repulsive? This all depends on the position of the magnets and if the same or opposite magnetic poles are facing each other. The strength of a magnetic force depends on the strength of the magnets and the distance between them, how the magnets are positioned compared to one another. You see, it turns out that each magnet has a north and south pole. But what does this have to do with attraction or repulsion? Well, as you may have heard, opposite attract. So, if you face the north pole of one magnet to the south pole of another magnet, guess what? Okay, so they will be attracted to each other. But if you turn one of those magnets around so that you have two north poles facing each other, then they will repel.
So another types of force is frictional force. So frictional force is a force that opposes motion between two surfaces that are in contact. It goes by the irregularities and imperfections in the surfaces of objects, which make it difficult to slide or roll over each other. Frictional force is a type of contact force, meaning that it only occurs when two objects are in direct contact with each other. So some examples of frictional force are walking, because when you walk, your foot pushes against the ground, and the ground pushes back with an equal and opposite force. This force is a frictional force, and it is what allows you to move forward.
Another type of force is the nuclear force. Nuclear force is the force between two or more nucleons. The nuclear force is about 10 million times stronger than the chemical bonding that holds atoms together in molecules. The release of energy when a nuclear weapon is detonated is due to strong nuclear forces. It is also used in nuclear power plants to generate heat for the purpose of generating energy, such as electricity. In an atom, the electrons remain in the orbits due to the electromagnetic force between the negatively charged electron and positively charged electron.
What is electromagnetic forces? Electromagnetic forces are like invisible hands that push or pull things, but they work with things that have electricity in them. You know, like the electricity in your toys, lights, and even in the screen you're looking at right now. So there are two main parts to understand. We have electric charges and a magnetic field. First, what is electric charges? Imagine tiny particles called electrons. They're like really small pieces that make up things like your toys and even you. Some electrons have a special property called negative charge, while others have positive charge. So they are like magnets. The same charges push each other away, but opposite charge pull together. Next, what is magnetic fields? Think of a magnetic field like an invisible blanket around things with electricity. When you turn on a toy with the batteries, it has a tiny magnetic field around it. This field can push or pull things that also have electricity. It's like when you try to push two magnets together, they either stick or push away. Now, when you have electricity moving around, like in wires or in a battery, it creates both electric charges and a magnetic field. That's why when you play with magnets or use electronic devices, you're actually experiencing an electromagnetic forces. These forces are super important in our everyday life. They help make your toys work, they power your video games, and even let you talk on the phone. So next time, when you turn on a light or play with magnets, remember, you're experiencing the power of the electromagnetic forces.
So children, what is motion? Motion is defined as a change in the position with time. So, for example, when an object is moving from point A to the point B, it's changing position with time. We have solved that the time is also changing along with the position, so it is undergoing motion.
Newton's laws of motion. Now, here's where Sir Isaac Newton comes in. He was a brilliant scientist who discovered three important rules called Newton's laws of motion. He came up with these rules a long time ago to help us understand how things move. It's like the instruction manual for how everything works around us. The three laws of motion were first stated by Isaac Newton in his Philosophia Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, originally published in 1687. Newton used them to investigate and explain the motion of many physical objects and systems, which laid the foundation for classical mechanics. Newton's laws of motion are three basic laws of classical mechanics that describe the relationship between the motion of an object and the forces acting on it. These laws can be paraphrased as follows. A body remains at rest or in motion at a constant speed in a straight line unless acted upon by a force. When a body is acted upon by a net force, the body's acceleration multiplied by its mass is equal to the net force. If two bodies exert forces on each other, these forces have the same magnitude but opposite directions.
What is law of inertia? Law of inertia, also called as Newton's first law, postulates in physics that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in straight line at constant speed unless it is acted upon by a force. For example, if you roll a ball, it will continue rolling unless friction or something else stops it by force.
The Newton's second law of motion is what we call law of acceleration. It states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two things, the force and mass. It also states that the time rate of the change of the body is equal to both magnitude and direction to the force imposed on it. Acceleration depends on net force. If the net force is higher, then the acceleration will be higher too.
Law of interaction, also known as Newton's third law of motion, deals with how different forces interact to create motion and help us understand what happens when two moving forces meet. To put it simply, law of interaction states that for every action, there is opposite and equal reaction. An example of this law is playing tag of war. In this activity, the rope is the means to transfer forces. The first team to tag is the action force, posing the pole on the rope as a reaction force, the other team's rope and feels the pull.
So let's have a brief review discussion about the topics that has been discussed. But first, do you know that Isaac Newton was the first to discover the relationship between force and motion and came up with these three laws of motion, which are the law of inertia, law of acceleration, and law of interaction. So let's go back to the topic. So what is the relationship between force and motion? Force is described as the amount of pressure that is applied to an object and it makes an object move. And motion is the change of position or certain movement of an object as the result of the net force acted on it. When the force is applied, it changes the position of an object concerning time resulting in motion. Force affects the state of motion and it can cause motion to happen and it can also cause it to stop.
Again, there are 5 types of force, which is first, gravitational force is the force of attraction between all masses in the universe. Second is frictional force, is the force generated by two surfaces that contact and slide against each other. Third, nuclear force is a force that acts between the protons and neutrons of atoms. Fourth, electromagnetic force is a type of physical interaction that occurs between electrically charged particles. Last, magnetic force, attraction or repulsion that arises between electrically charged particles because of their motion.
So now let's move on to the three laws of motion. The first law of motion is the law of inertia. Inertia is the continuation of object in its current motion until some force causes its speed or direction to change. Example, stirring of coffee. If you stop stirring the coffee, the movement of the coffee doesn't stop immediately, and that explains the law of inertia. The law of motion is the law of acceleration. Acceleration is the rate at which velocity changes with time in terms of both speed and direction. Example is a car speeding up. And another example is a ball rolling down the slope. The third law of motion is the law of interaction. This law deals with how different forces interact to create motion and helps us understand what happens when two moving forces meet. An example of this is pushing the wall. If you apply force on pushing the wall, and the wall also exerts equal and opposite reaction. And that explains the law of interaction, where both the two objects exerts equal and opposite reaction.
It is a physical quantity that describes the interaction between two objects. Okay, Miss Navita? Force. Very good. It is a force. Next question. It is defined as the change in position of any object. Okay, Miss Lanman? Okay, very good. Let's give her a round. So, what are the three laws of motion? Okay, give me one. Miss Aini? Law of inertia, correct? Next, Miss Agza. Law of acceleration. Very good. The last motion. Okay, Miss. Okay, very good. That are the three law of motion.
the law of inertia, law of acceleration, and the law